Once we run the command Python 3 ext analysis, the code spawns up a web instance in our browser, and then we paste the Metamask web store ID and click and analyze, save it to a file, and then check the terminal. The tool fetches lots of useful information about the extension like IP addresses, wallet addresses, functions. And when we try to paste these two addresses together, it returns a denied request, allowing only one request, but due to the flaw, you can query three addresses and get a balance, token, and flag output. Hey, hello hackers. Over the years, security research has emerged through different technologies from web and mobile apps, hardwares, cloud, blockchain, and so many more use cases where security platforms like HackerOne, Integrity, Crowd, Microsoft, Hunter, and so many much more have created ways to cover these issues from various technologies, and lots of hackers have been able to find these issues from different endpoints and newer products. So this boils down to what we'll be checking today, which is browser extensions. So if you're a pen tester, bug hunter, cyber APT, or whatsoever, you might want to add this to your hacking process or your box of cheat sheets and tricks. So when hunting for bugs on browser extensions, the main goal here is understanding the purpose of the extension, how it works, whether it's a subset of the main branch of the application functions. So if you don't understand much about finding bugs on browser extensions and need a tip or a guide to put you through the types of bug hunting techniques, check out the links below as we'll be performing Recon on a live target with a web hacking demo of a Web3 browser extension. And if you have good experience in software editing or web app hacking, you might want to check out Hunter AI today, our today's sponsors. And don't forget to hit the bell icon and subscribe button. Thank you. Introducing Hunter AI by Protect AI, the only artificial intelligence and machine learning hunting platform out there that empowers security researchers with the freedom to test for vulnerabilities in open source software with over 180 plus scopes. The platform simplifies the vulnerability disclosure process for both security researchers and maintainers. Hunter provides bounties to reward security researchers who discover impactful vulnerabilities and maintainers who promptly fix them. To get started, you simply register by clicking the avatar above and authorize your GitHub account to the Hunter page. So now head up to the bounties page. Check for a technology or application you are most comfortable with, then select it and you can read the scopes, or just head up to the repository page, and if you found a bug, hit the submit report and fill in the info about the bug, and that's it. We have found our first bug on Hunter platform. And one thing I love about the Hunter platform is the active and reliable community on Discord, the ability to view any reports and also make comments on those closed reports, and the getting started page also that gives detailed explanation about bug hunting for beginners in general. So join us in creating a safer AI ecosystem. Visit Hunter AI today to start hunting for bugs and making a difference. We'll be performing a little recon on Metamask web extension. I'm using Brave browser, so I'll be using Chrome Web Store to install the extension. If you use Firefox or any other browser, all these steps will still work as usual. So I'll be using varieties of tools and steps here to do this recon demo. So trust me guys, this will give you an upper hand when hacking these Brave browser extensions. So let's start by clicking on the add extensions button, and once this is done downloading, then I will pin the browser here. And alright, so let's use this extension just as a regular user would do by creating a new wallet or importing one to, if you already have a wallet, then I will set my password and every other details. So once this is done, we can explore the interface by trying to test for every other input. So up at the right, you can see that we have the change networks option from each one to other networks in the blockchain. So we can also add our own networks, and this gives me a good clue of figuring more functions out in the extension. So we can also check the middle modal, which displays the account sections on the Metamask extension. So let's try to add another account, maybe try importing it instead of typing a new account. So I'll just pass the wrong file format for JSON here, and to see if there's any error in input handling here. And we see that the error says unexpected token. Cool. So when I was testing this earlier, I figured out there are a couple of ways to do Recon and understand this extension better. But first, when we go to the account details in the nav handle, we see the same error output there. So if you're a bug hunter, I know your 6 cents would have to run Burp suits, but usually the protocol headers used on web proxies like Burp would never recognize Chrome extensions headers, even if we use coil. But I found a way around this to still use Burp suit to intercept requests. But first, let's try to abuse and manipulate any transactions on the Metamask account to another wallet. So I will just add a new contact and add a name and wallet address. Since I have no deposited to this wallet address, I will try to see if I can see any request or queries using the dev tools, as the Chrome extension will probably recognize this protocol. So when I start the transactions, we can see the errors below. We then use the window location string to check if it has dump strings, values, post messages, or events, and we see the data is being used here and it has a dump string value. And we can also try the window.location.hash/1 to see the endpoints where we are currently, and we can also check the network tabs to see that there's no request made here. Okay, now we begin to think, what can we do? We can do source code auditing by putting through every code and trying to find an error or a flaw, but that would be stressful. But since we were left with no proxies, we can just throw a casual eval alert1 string in a console to see if any errors pops back, and we get blocked by the CSP and security features used by Metamask, which is lava mount they integrated. You can go around the ghosts trying to pull up each code and understanding what the lava mounts or sentry blocks, but we won't be doing that. Instead, we'll try to get the internal HTML content of any HTML element to see if it blocks our query. And we test for this using the file.init.html. Don't worry, it's not so. And we see that it's not defined. So okay, we can define the function and see if lava mount can still detail what we're trying to do here. So we use the function show to define the function, and the var file equals to the link dot import query selector, and we're going to the body. So we're just creating a variable file and linking the query to the body, and we run an alert file.init.html to alert the HTML content. So, and when we execute, you see that the output is undefined. Actually, yes, because there's no other variable like this. So this is good because now we know that Laravel doesn't care about internal HTML content, or maybe it uses this for other contents. So let's just keep testing other functions. So now let's reject this and try to buy a token. So we get redirected to a payment gateway. Okay, now I understand JS well enough to know that these payment gateways these days mostly use post messages functions, which sends data locally between window objects and does not generate any HTTP requests to send data. So since we can't capture the request for the post messages on console or the network tabs or even a proxy, so we improvise using a extension called poster and post message tracker from GitHub. To install this, just clone the repo, go to the browser settings, head up to extensions, manage extensions, click to load the extension, and voila. Alright, so let's try to buy or sell each one from our mainnet, and we are being redirected to the payment gateway from Metamask. So let's try to purchase one or so. So when we check up our post message tracker extension, it has noted that the parameter of this. So if you're a lover of post message vulnerabilities, you can hold it up for letter expectation, and you can also use the poster Chrome extension. I love this too because it actually actively logs the request for you, and you can actively code in its instances also, and fetch. It can also fetch and paste responses for you automatically. So having all this information has become useful, and we can check out for more functions in the extension. So to find this post message functions or any other issue, let's head back to the settings, and we see that there's a network settings down there. So let's check it out and try to add our own network now. So this is a bit complex if you're unfamiliar with coding and Web3 overall, but trust me, I'll make everything easier here. So we specify our network name. So I couldn't get the VPC address for this video, so instead I prefer to use my own track me OpenVPN IP as an RPC endpoint, and we'll spawn up Wireshark to make sure every request are being logged on our tunnel address. So I will set the RPC URL to my track me OpenVPN as usual, and if we run on nmap scan and nmap-a-pn with the IP address to figure out the ports on the tunnel address, we can see that we only have our port 22 for SSH tunnels. So we can just start up our Apache service on our terminal. So I created a little exploit.html that was linked to JavaScript functions above, and I moved it to the file.html directory and added it to our Etsy host as usual, and then we head back to our endpoints on our browser and it's blank. So we open our console and wait, and then we head back to the Metamask extension and try to add this URL endpoint in pin, and we see that and we check the exploit page back and we see that the requests are coming through from our poster web extension and forwarded back to our endpoint here. So this looks cool, right? And so we'll try to build up a smart contract here so that we can hack it better. So but first we check the responses from the Metamask console as it's trying to fetch requests from our endpoint. So if we try to impute random functions here, we'll just be ignored with the issue. So I did a bit of research, and we need to actually build our smart contracts like using hard hat development environment. So well, if you don't know much about all this, so just use the I believe everything here button and follow along everything for keystroke, right? So this is the documentation page to set up a smart contract. So just follow the instructions blindly and install what's on the documentation. It's very simple. I have already installed this smart contract, and I'll just run it instead, and from the install directory, of course, and boom, we've locally hosted our own smart contract, and we can edit the URL as the smart contract RPC URL and set our chain ID to 31337 with the currency symbol as Go or ETH. So when we check our exploit endpoint, more responses begin to drop as the Metamask extension now treats our smart contract as its own network. One thing that caught my eyes through this whole process was the login done by the Addon tool. I saw that the extension configuration that Metamask uses isn't properly configured well to accept these types of development contracts. So I began using my address to test for other test cases, and I noticed more errors logged back to the terminal. So I thought if there was a slight chance I could pass through the proxy to see what happens here. So I launched my Burp suite and I tried to use my collab URL and append to my Etsy host file next to my OpenVPN IP address. And when I headed back to the Burp collab URL on my browser, it showed the index server, and on my Burp I received my request. So this is all active now. Now this becomes easier to proxy through. So first we have to change the network URL to our proxy URL, like SSRF, to check the requests and to see if the HTTP is actually active. And we head back to our Burp suite and we see our HTTP is actually active. So we copy that request and paste it on a repeater, and now we set up the host as the smart contract URL endpoint. And you must be wondering, will this also work? Actually it would, and it did, but it works because of the endpoint of the smart contract is originating from my localhost, which communicates with the tunnel address and which has an alias of my Burp collab URL. So which means we can proxy through it or any other extension and that accepts outbound requests just by simply changing the origin header to the respective extension ID. So to test for this, so we can try to transfer to another wallet, and then we copy the URL endpoint and above and replace it as the origin header, and the request gives a new response. So Feels good, but on the long run, it will be a stressful use case. For example, if you're trying to modify the content of the Metamask extension, you first have to set up the smart contract local server to function as you want it to be modified before an entirely different request can be made. So, for example, when we go back to the console, then we try a JavaScript alert at 7, it will throw an error of the lava mount protections. So we can still check the console tab on other placement, and we can see the messages of JSON file, and we see that there's a full scope of information about the code extension, and we need to process some other internal functions, right? So we can head back to the sources, and you can see some other source code and some other packages and other code also attached to this might be missing. So this will lead us to our next tool, which is the CRX extractor extension. This tool just originally downloads the raw source code, like how scraping is being done on web page. It scrapes the source code and saves it for source code review. So we start it on Google and we install the extension, and shortly we go back to our Metamask page and right click and hit the CRX extractor, and I will download the file as a zip. And once this is done, you can open it on a VS Code or any IDE of your choice, so we can skim through the source code of the files as it gives you an upper hand of as a hacker to understand the core workings of the extension. And we can modify and we upload them back to the browser to check if any bypasses were actually made. So to make looking for information disclosures or any sensitive files discovery faster from the extension, so we use a GitHub repo called ext analysis by Red Hat. So it's the browser extension analysis tool that actually analyzes the browser functions and separates each IOCs and keeps them in different records in different layers. So I will just clone this and set into the directory and use pip to install some Python requirements, and after that we will run the command python3 extanalysis.py. So the code spawns up a web instance in our browser, and we see that the ext analysis tool is running. So then we can copy our Metamask extension ID from the Chrome web store or the extension tab of our browser and paste this, and then analyze and save the analysis to the file and check the terminal. So the tool fetches lots of JSON information about the extension. So you might have to wait for the tool because it will fetch or grab any information from the source code relevant to the extension and output it on the terminal. So most times the information here on the terminal are mostly false positives or informational tips about the source code. So I'll just let this run till it fetches all the information it can find, and when we use the less command with the output file, we can see the information about the relevant IP address, wallet address, functions, queries, basis for, and so much more information from just these two. So if you want to scale up, and can go back to the web instance on our browser and click the settings, and we add our various total API key, and use various total API to constantly check for any relevant information it finds from the extension. And we check the tool as it gives so many options to customize and compile the information about the extension in graphs, form, and so much more. So you can check out the tool because it is a very great tool for analyzing the structure of web extension. So another tool we like to check is Node.js add-ons linter and Microsoft add-ons page. So they both work hand in the same way actually, but to use the Node.js tool actually, so we have to install the npm package. So we have to do npm install add-ons linter to install the tool. So since I already have this installed, so I will just run add-ons linter --help, and you see the options we have. Basically what this tool does is that it checks for any errors or misconfigurations on the source file before uploading to the extension web store. So from our help options, I will use the pretty option because it makes the display a bit more presentable, and I will use the full directory where the files were created, and we can analyze the errors from the extension. I will see that there are few issues from the packages that add-ons later discovered. So using the Mozilla Firefox add-ons page, we could find issues here around the extension by actively just uploading the CRX or zip file of the extension. So what I'll just do, I'll just upload the file, and when it loads and compile all the errors, it will come up with a fix and also tells us where these extensions are being located. So but As an ethical hacker with this knowledge, we can analyze the issues from the deposit function and compile it. We're just digging through the source code. So this is by far a gem to start exploiting and finding bugs here on the Metasploit extension. So this is also available on the Metamask bounty program. You can check it out if you want to find the bug on the deposit function or any other endpoint. So let's move up to the exploitation of our Web3 demo. So IT have configured a vulnerable Web3 browser extension for just testing. So to upload the extension source code to our browser, we go to the settings, the extension, we hit the manage extensions, we load the extension, put it on the base directory, and we can see the extension is now active, and we can pin this and start enumerating. So looking at this now, we can see that this is just an extension to check for any wallet H1 balance, right? So if I input my H1 wallet to check for my balance, it returns the balance. So analyzing the source code becomes useful here, because as an attacker, if you can discover the source code, you can discover the whole system. So I will use the EX analysis to once more. It gives better output about the code, the resources attached to the extension. So we will just save the extension as a zip file. After that, we can upload and analyze the extension better, as you will see the structure of how the extension is configured. The UI is actually great, as I can drag around this for fun. And there's also the URLs and the main sections to check for any URL used in the source code, and there's the file section to view any relevant files within the browser extension. So after that, we can check to see the files menu and consider there are two JS files, which is the service worker and the pop-up bundle.js. So the service worker.js is just having as a means to set up the extension into the browser. Nothing much interesting here. Then we can analyze the pop-up bundle.js and find the vulnerability here. So let me break down what happens here in the code. First, we set up an event listener that listens for a click event on the HTML element with the ID fetch balance when the element is clicked, and the function inside the event listener is then executed. So here the code retrieves the value of an HTML input element with the ID ETH address. It then splits the input by the delimiter and retrieves any white spaces from the resulting address. The addresses are then stored in an array named addresses. So now the function here checks the number of addresses in the input. If one of the addresses provided, it calls the get balance function to fetch their balance for the address. If three other balances are provided, it then calls the get wallet info function to fetch the balances only if the main functions are met. So otherwise it displays an invalid input. So if you look further, the code here defines the get wallet info function, which takes up an array of an address as an input. Inside this function, it iterates over each address, is fetching the balance and tokens for each address is used by the get balance function. So the balance retrieval here function just defines that it will take up the address as an input, and inside the function it constructs a JSON RPC request to fetch the balance of that given address from a specified API endpoint and sends it to the fetch API using fetch API, and processes the response to extract and return the balance. So if an error occurs during this request, it returns an error message. So overall, this code sets up an interface for fetching and displaying the balances and token information of one HTML addresses with error handling for invalid inputs or API requests. But we now understand the full control of the code. We can start to trying to abuse the input string of the above delimiter, which trims any white spaces from each resulting address. So we use this as an injection point, because if I use my first wallet address, it fetches the balance as usual. But if I try to input two wallet address with the delimiter sign, you get a denied request. Only one address is allowed as a response. So since we know that the address validation has address length of 3, so we can keep trying to append these addresses together with the delimiter sign, and when we append this for the third time, we get the information leak and call out the flag, the wallets, tokens, and so much more. So if you want to get a hang of these two, click on the GitHub link below and follow the same instructions to set this up. So a small teaser here. What type of vulnerability would you classify this demo as? Leave the answer in the comment section below if you've enjoyed this content, and also drop a thumbs up and subscribe for future contents like this. Happy hacking. Bye.